Hello. Welcome to this webinar offered through DairyXNet. My name is Kathy Lee. I am an Extension Educator with Michigan State University, and I'll be today's moderator. The title of today's webinar is New Tools for Dairy Reproduction Programs, and it will be presented by Dr. Paul Fricke from the University of Wisconsin-Madison. Dr. Paul Fricke was raised on his family's row crop and dairy farm in Nebraska. He completed a BS degree in animal science from the University of Nebraska in Lincoln and an MS and PhD in reproductive physiology from North Dakota State University. Dr. Fricke has been a faculty member in the Department of Dairy Science at the University of Wisconsin-Madison since 1998, where he has extension and research appointments in dairy cattle reproduction. Dr. Fricke, at this time I turn over the program to you, and we look forward to learning about recent research on new tools for dairy cattle reproductive management.
All right. Great, Kathy. Thank you so much for that introduction. It's just a pleasure to be here. Thanks for the invitation to do this webinar, and welcome to everybody out there in cyberspace listening to the presentation. So the talk that I put together is entitled New Tools to Manage Dairy Cattle Reproduction, and reproduction is important for a dairy. It's a driver of dairy cattle profitability, and it really drives a lot of development of new tools that periodically come out and are available to dairy producers. And one of the things that I like to do with my applied research program is to take a look at some of these new tools and see how they might impact reproduction, whether they improve it or in some cases may actually decrease reproductive efficiency depending on how those tools are used. So the three things that I'm going to talk about today, number one, the accelerometer systems for detection of activity associated with estrus behavior. I'll quickly go through a study we recently have done on strategies for resynchronization of ovulation. And I'm going to wrap up with some new methods for non-pregnancy diagnosis. So that's the outline of my presentation this afternoon, and we'll get straight to it. This is a hot topic, I would consider, these accelerometer systems that have kind of hit the marketplace. There's really two systems that predominate out there. There's others that are available as well, but the two big ones are the SCR system, or SCR heat time system. It's also called the AI24 system. The other one would be a system developed by Select Sires called Select Detect. Those would be the two big systems. I'm showing a picture here of a Lely robotic milking system. I was actually just over in Holland. They've got a lot of those systems over there. These systems are also going in many farms in Wisconsin. And I just show that because they have an add-on heat detection component, and that component is this SCR system. So when just want to show you how these systems are, what they look like on a dairy. So anyhow, you can see a cow here in a headlock, or actually in a parlor, and you can see on the side of her neck she's got two collars on. There's the green collar that is the accelerometer itself. Okay, there it is. Okay. So here's the accelerometer. It resides on the cow's neck. It's monitoring estrus activity 24 hours a day, 7 days a week. So in theory, we've got constant surveillance of estrus activity. And then this cow will walk through this archway 3 times a day when she's milked. And up here you can see there's two readers, and this is just a close-up of the reader down here. When the cow's tag gets in close proximity to that reader, it uses an infrared signal, wireless signal, to actually download the data from the collar. So what we have now is a system to watch for estrus. And you can see this is the kind of a graph that is generated by this system. What the tags will do is determine the baseline activity of the cow. So the cow's going to, she's have some lying time during the day. She's going to get up to be milked 3 times a day. She's going to walk to the water in the feed bunk. But as you can see, that's going to constitute her baseline activity, which is set at 0. And then when a cow comes into estrus, what happens is estradiol 17 beta, it's an estrogen from the follicle, is going to get high, and it's going to cause this cow to increase her physical activity. And so she's going to move around a lot more, and you can see this dramatic increase in estrus activity followed by a decrease in estrus activity. And one of the questions that we had that we wanted to answer is, how uniformly do cows ovulate after this increase in activity? And there's really two different possible outcomes. This could be a really good predictor, this increase in activity, of the timing of ovulation, or there could be a lot of variability among cows in the timing of ovulation. And this is important. It's an important question because the timing of insemination in relation to ovulation is a primary determinant of fertility in these lactating dairy cows. And so that's what these systems do. They detect estrus, and they essentially tell you when to breed these cows. And so I just want to show you the first experiment that we did then to answer the question. This is just a screenshot then of me and my students. I would like to say that my students are always smiling. So here's Alessio. He's a veterinarian from Italy who worked on this project. And over here is Glaucio. He's a veterinarian from Brazil who did his master's degree with me. And this is just a screenshot of the publication. It just came out in the Journal of Dairy Science not too long ago. So what we did is we had a collaborating farm. This farm was Majestic View Dairy in Lancaster, Wisconsin. They're milking about 1,000 cows. And they had already bought the heat time system. We simply asked them, can we play around with your cows and ask a few questions regarding these systems, because I was getting an awful lot of questions about them. And so the experiment that we decided to do, again, what we're trying to figure out is when do cows ovulate in relation to estrus behavior. So what we did in this experiment is we took 112 of their cows, they're between 46 and 52 days in milk, and we synchronized estrus. And we did that by using a protocol in which we give GnRH, and then 7 days later give a prostaglandin injection. This is 2/3 of an OVSYNC program. What we did is simply left off the last GnRH injection. And what this GP protocol will do then is synchronize ovulation in a pretty tight fashion. So we ultrasounded and took blood samples at the GnRH, ultrasounded, took blood samples, and we put a KMAR on. That's a pressure-activated device on the tail head of the cow to determine if she came into heat. And all these cows had the heat time system in place. And so what we would do then is we only took synchronized cows. So we had to remove 23 of the animals that were not synchronized. They had to have a corpus luteum at the time of the prostaglandin injection. They had to regress that corpus luteum by Wednesday. And they had to have a follicle greater than 10 millimeters in diameter at this prostaglandin. So we took 23 cows out. So we ended up with a total of 89 cows. Then what we did is Alessio went to the farm on a weekly basis. He stayed there Wednesday, Thursday, and Friday and ultrasounded the cows. After they left the parlor, they went into a management rail system, and he could determine whether or not the cows ovulated during this time period. So we get a precise timing of ovulation here, and then we checked again here on this Monday to determine whether or not the cows had ovulated. Now, I would have expected a high proportion of these cows to come into estrus, because they're all perfectly set up to come into estrus, and we took out the 23 cows that were not perfectly synchronized. So let's see what happened in this experiment. In the left-hand column, you can see data from the accelerometer system. Of the 89 cows that were synchronized, the system only caught 71% of those cows in estrus. So interestingly enough, it's not as high as I thought it would be. It's only 71% of the cows that were perfectly synchronized did we catch in estrus with the accelerometer system. The good news for the accelerometer system, if it detected the cows in estrus, 95% of those cows we detected an ovulation in. So that's good news, because you want the cow to ovulate if the system says she's in estrus. Only 5% of the cows did not ovulate. These would be a problem because the system would in fact say they were in estrus, and you would go ahead and breed those cows, but unbeknownst to you, they would not ovulate, so this small percentage of cows would not actually have a chance to conceive. That's not a big problem. We know that that happens in some cows. Here's the bigger problem. 29% of the cows did not show estrus, and of those cows, 35% of those cows, we detected an ovulation. It was 9 cows out of 26 that did not show estrus. If you look at the total, 9 cows out of 89 cows, it's about 10% of the cows in this data set were ovulating without showing signs of estrus, or at least enough signs of estrus to be called in estrus by the activity system. The other problem is 65% of the cows that did not show estrus did not go on to ovulate. These would be kind of some sort of an anovulatory type of a cow, although they had a CL based on the synchronization system, so it's kind of an interesting biology that's going on. So one thing I always tell people about these data, this is not a problem with the system. If the cow is showing estrus, the system will detect her in estrus. 95% of those cows go on to ovulate. It's a real cow biology problem is what we're dealing with. We've got cows that are ovulating without showing enough signs of estrus to be detected by the system, and we've got a group of cows that in fact are not going on to ovulate. This column just real quickly shows what's going on with the heat mount detectors, and it really reflects the same thing that's going on with the accelerometer system. Real quickly then to go through the data. As I said before, the interval from artificial insemination to ovulation is important for determining fertility. We want to breed the cows about 8 to 10 hours, 8 to 12 hours before they ovulate, and the average in this data set was cows were inseminated 7.9 hours before they actually ovulated. The problem we ran into in this data set was that these cows on the left are inseminated too late. They're inseminated after they ovulate. The cows over here on the right are inseminated way too early. The ones in the middle are the cows that are inseminated just right. So again, we're starting to get an answer to our question. Is the onset of activity a real precise indicator of when to breed the cow? And it ends up it's not. There's a lot of variability in when cows actually ovulate, and this variability is going to cause problems with conception rates. One other thing I need to mention here, this farm was inseminating cows twice a day. So they would generate a list in the morning and go out and breed, and they'd generate a list of cows in the afternoon. That's been my recommendation for farms using these systems. I think you have to breed the cows twice a day. Not breed cows twice, but go out and breed twice a day in order to minimize the variation that you see on this particular graph. I just want to contrast that variability with what happens in a synchronization program. Here's the GP protocol. What we do with an OVSYNC program is we give a second GnRH injection to induce ovulation. If we didn't give the GnRH injection, as I showed you before, cows would come into estrus out here. There'd be a lot of variation into when they ovulate. But when we give this GnRH injection and induce the ovulation, ovulation is induced within a very tight window, about an 8-hour period, so we can select the right timing of ovulation. So one of the things we do with a synchronization system is we get the timing of ovulation, the timing of insemination in relation to ovulation just right. And just to show you some data on that, these are older data. Cows inseminated at different times in relation to the second GnRH injection of OVSYNC. If you breed them at the same time, that would be a co-sync, time 0, 37%, goes up to 45% if you wait till 16 hours, and then it heads back down to unacceptably low levels if you breed them too late. This is where the recommendation of breeding about 16 hours after the second GnRH of OVSYNC came into play. So what we see happening with these systems, I have no problem with these systems being used. They actually work quite well to detect the cows that are in estrus. I've been telling people about 71% of or 70% or so of the cows you'll catch in heat on your farm. But one of the mistakes I think that people are trying to make with these systems is this is a graph of date of calving by days in milk at first breeding on the y-axis. On the left-hand side of this graph, what you can see is that the farm is using a pre-sync OVSYNC protocol. The second prostaglandin is given at day 50. They cherry-pick cows to estrus after that second prostaglandin, and any cows not caught in heat then go through the OVSYNC part of the program. And the advantages of doing this is you can control your voluntary waiting period, you can control the maximal days in milk when cows are inseminated, and you breed all cows. 100% of the cows that go on the program actually get inseminated. What this farm did then is at this point in time they decided we're going to buy an accelerometer, which I have no problem with. But what they did then is they said we're going to completely stop synchronizing our cows. And so what usually happens is you see an awful lot of cows are detected in estrus. You'll catch about 70% of the cows to an estrus. And then what happens is an old problem that we used to deal with before synchronization systems. A lot of cows go a long time without seeing any insemination, and about 30% of the cows aren't being inseminated. So after a few months, usually someone on the farm says, wait a minute, we're not breeding a third of our cows. What this farm did is something I would prefer. They put a pre-sync OBSYNC program back in the herd. They're breeding to estrus after the second prostaglandin, and they put the OBSYNC part of the program back in there, which is very important. So I want to kind of expand on that a little bit. So we realized very quickly that if you're going to use an accelerometer, you really need to blend some level of synchronization along with estrus detection. And I think that's by far and away the best way to go. And so this is the second study that we conducted on the same farm. I'm still working on the paper. But what we did is we submitted cows to 3 different treatments. I'm not going to talk about treatment 1. I want to compare treatment 2 and treatment 3. What we did, this is a pre-sync OBSYNC protocol that many of you are probably familiar with or using on your farms. So a 14-day interval between the 2 prostaglandins, start OBSYNC 12 days later. The difference is if cows were detected in estrus in treatment 2, they were inseminated. And this is estrus based on the accelerometer system. If they weren't detected in estrus, they were submitted to the OBSYNC protocol. Treatment 3 is the exact same protocol. If they were in estrus here after the second prostaglandin, they were not inseminated. Instead, 100% of the cows went all the way through the timed insemination program. And the reason we did this, one of the questions I get very commonly with this protocol, should I breed my cows to estrus after this prostaglandin, or should I not breed my cows to estrus? And I'll just set you up for the answer. The answer is it depends, and we'll get to that in a few minutes. So just briefly to show you what's going on in this experiment, we had good numbers of cows. It took us a year to enroll cows into this experiment, so over 300 cows per treatment. And what you'll notice in treatment 2 is that you actually breed cows the earliest in relation to your voluntary waiting period, 62.6 days to first AI, versus 74.8 days to first AI, because these cows, we wait till the time of insemination. So the advantage goes to treatment 2 because they're bred earlier. But what you see then is the average conception rate in treatment 2 is lower than in treatment 3. It's 31% conception rate versus 38% conception rate. So the advantage here goes to treatment 3. And I will come back to this from an economic standpoint. So let me just show you what happened in this experiment. Again, all cows had accelerometers on them. They're going through this pre-sync program. How many of your cows will you detect in estrus after these 2 shots of prostaglandin using an accelerometer? It was about 70%. And those cows, when they were bred, had a 29% conception rate. And I just want to comment on that conception rate. I generally don't like to see conception rates less than 30%. This is kind of right there. And is this true for every farm using an accelerometer system? No. But on this farm, for whatever reason, the conception rate was low when they were breeding cows to estrus. So you catch 70% of your cows in estrus based on the activity system and you breed them. That means that 30% of your cows go into the OBSYNC program. And amazingly enough, the conception rate here was 35%. And the reason I'm surprised at that, if cows start OBSYNC in a low progesterone environment, which if you caught all of your cycling cows here, you would imagine only your anovular cows were left, we generally see conception rates in the low to mid 20% range. These are typical of an OBSYNC program, catching some cows with and without a CL. In fact, we have data on proportion of cows with a CL here. It's over half of the cows actually have a CL, and that's reflected because cows are ovulating and not showing signs of estrus. So the point here is that the OBSYNC part of this program deals with the cows that you can't catch in estrus. And it deals with them very effectively, about a 35% conception rate. So it is curious to me why people are interested in completely eliminating this part of the program when it brings so much to the table for getting cows inseminated for the first time and dealing with these cows that we can't catch in estrus. Now what I want you to remember here is the 69% and the 29%, because when we compared that to the cows that came into heat, but we didn't breed them, they went all the way to the time to eye, again, it's 70% of the cows, we were able to increase the conception rate to 41% by 12 percentage points by not breeding cows to estrus. And that's because the cows that come into estrus here are set up perfectly to start the OpSync program. And that's why we give these two prostaglandins. We want our cows to come into estrus so that we start OpSync between about day 5 and day 12 of an estrus cycle. So that's why we see higher conception rates. Again, the OpSync cows, 30% of them at a 32% conception rate. So it was a very interesting study. For the interest of time, I'm going to skip over that. I want to get to this, and I want to show you this model. If you Google Victor Cabrera, you'll get to his website. I think he did one of these webinars. Maybe he did the last one right before I did. This is an economic calculator, and what we did is we just simply put the data from the study I just showed you into this economic calculator to ask the question, which one of these systems, breeding to estrus after the second prostaglandin or not breeding to estrus after the second prostaglandin and doing 100% time to eye, which of these systems is preferable? When we put our data in that calculator, and I'm not going to go into the nuts and bolts because I think Victor went through that pretty well in his webinar. Again, we're comparing treatment 2 and treatment 3. What the model does is it gives you the net present value in dollars per cow per day, and you can see that the data that we had, remember that I was saying the advantage goes to treatment 2 on the service rate side, but the advantage went to treatment 3 on the conception rate side. Those two completely washed each other out, and we came up with the exact same net present value. So the answer, which one is better, with the data in this experiment, they were equal. Now you can play around with this calculator and find out, based on your conception rates, which should you do. Should you breed more to estrus, or should you breed more to time insemination? That's going to vary from dairy to dairy. A couple other things we looked at. These accelerometer systems have a high upfront cost, and it can be a very large cost. This would be for 1,000 cow dairy, buying 500 accelerometers and the base equipment that you need to put it in. That's $72,500. It sounds like a very large number, but if you amortize that number, that money, across, say, an 8-year time period, and you look at the activity system cost in dollars per cow per day, it comes down to less than 3 cents per cow per day. This cost, interestingly enough, is about the same cost as it would cost to hire people to tail chalk your herd or watch the cows in estrus. So, two things. These systems aren't as expensive as they seem up front. They can be very economical. But number two, they pretty much transfer costs from either watching for estrus or actually buying a system that's going to watch estrus for you. So that's just a little bit on the economics of this, this particular system. The last thing I'll mention is that the systems are going to continue to get better. SCR has a new software system called the DataFlow 2 system. They've got a new tag called an HR tag. H stands for heat detection, R stands for rumination. And I just want to show you that very quickly. This is the graph. This is the new software. The green line is showing a cow in estrus here, and she's in estrus here. This is the activity. This is activity change. So you can clearly see the cow is in estrus. And the purple line is the weighted rumination change. When a cow comes into estrus, look at what happens to her rumination. Rumination drops dramatically. And when I've talked to dairy farmers who have bought this particular system, they like the estrus detection part. I think they learn on their own that you'll never catch all of your cows in heat. You're only going to catch about 70% of your cows in heat. They love the rumination part of these systems. So I'll just close this part of my talk and say these systems are kind of exciting, new technology that's hitting us, and it's going to be interesting to see where we go with that. Okay, on to my next section, technologies for resynchronization of ovulation. This is an area that I've worked in for a long time. Just to frame the problem, in herds that are doing a lot of synchronization and resynchronization, conception rates to first breeding can be relatively high. Here I'm showing you a farm that's running a 47% conception rate to first breeding. The second and greater breedings, however, drop back considerably. back into the 30% range. And the thing that a lot of dairy farmers have been asking is, why can't we do as good at the later services as we are at the first services? And the one thing I want to show you is that we can increase these conception rates to the resync breedings. It's just that we have to do a little more to get the cows properly synchronized. And so this is another paper, and this one's just been accepted to the Journal of Dairy Science, so it will be coming out in the journal very shortly. We did this on a large dairy in Wisconsin. You can just see a picture of the students here out working through the barns. It takes an awful lot of time and effort to get these things done. We asked 2 questions in this study. The first question, so cows were inseminated. First question is, do we start the resync on day 32, or do we start the resync on day 39? Why day 32 versus day 39? In the upper Midwest and the East, I would say day 32 is a very popular time to start the resyncs based on some data that we've published in the past. In the West, they resynchronize starting at day 39, so we just wanted to compare that. Then we asked the question, is there anything we can do to set the cows up to start this protocol, kind of like we would pre-synchronize the cows for first breeding? So we gave them an injection of GnRH 7 days before they started the resync protocol. And so you can see that here. So we're looking at a GGPG type of a protocol. The data are very straightforward. There was no day effect. It didn't matter if you resynced on day 32 or day 39. The conception rates were about the same. That's the average of these 2 bars versus the average of these 2 bars. If that's the case, the earlier resync is better because it has a higher service rate. What we did see is that giving GnRH a week ahead of time had a statistical increase in conception rate of about 5 percentage points. That's these 2 bars versus these 2 bars. So based on that, one of the recommendations we've been making is to come in 32 days after an insemination and set up the cows with a GnRH injection. 7 days later, the cows can be pregnancy checked, and a lot of veterinarians are using ultrasound. And so at a day 39 ultrasound, you determine whether or not the cow is pregnant, and you determine whether or not she has a corpus luteum. 82% of the cows, at least in this data set, had a corpus luteum. If they have a CL at this time point, you can simply finish the OBSYNC program, and you'll get normal fertility. The problem comes in with these cows. It's about 18 to 20% of the cows will not have a CL. These cows have about a 10% lower conception rate. So what can we do differently with these cows to try to help them? One thing we can do is restart OBSYNC. So these cows essentially get the GGPG protocol I was just talking about. And another thing that I'm not showing the data today, we're just submitting a manuscript looking at no CL cows getting a feeder insert at this time as well, and that also can be beneficial. So again, it's kind of a 2-pronged way of dealing with the cows. In the resyncs, I think it's a nice way to go. I'll be interested to see if there's any questions on this, and I know there's quite a few farms and veterinarians out there that are doing this kind of a strategy. Okay, last topic. Technologies for non-pregnancy diagnosis. The latest thing that's happened in this area, I worked with ultrasound for a long time, and ultrasound, I believe, has been adopted by a lot of veterinarians, a very common way to do non-pregnancy diagnosis. But this technology that I'm talking about here is the use of these chemical pregnancy tests. These things, the technology has been around for a long time, but perfecting it and getting it commercialized has taken an awful long time. And so first came out these pregnancy-specific protein B assays by Garth Sasser in the mid-1980s. People were talking about these, and it's not till recently that they came out. We call these things pregnancy-associated glycoproteins. I'll call them PAGs. And there's 3 commercial tests. The Bioprint test, IDEXX Laboratories has a test that's available, and DG29 is a 3rd test. They're all looking at the same class of molecule. They're these pregnancy-associated glycoproteins. So let's take a look at these. One of the things we need to know about using these tests, PAGs come up very slowly and late during gestation. The earliest we can detect PAGs reliably as a pregnancy diagnostic in lactating dairy cows is about 30 days post-breeding. And that's because it takes a while for the placenta to mature, the cells to migrate, and these PAGs to be secreted. So you can't check earlier than about day 28 to 30. The other thing that happens with these PAGs is they get very high during gestation. The cow will calve here, so the calf is expelled during the birthing process, during the parturition process. But the maternal system is full of these PAGs, and these PAGs have a half-life. It takes about 60 days to get the PAGs out of circulation, so you cannot do a pregnancy test before 60 days post-calving. So those are the two things you have to remember, 60 days post-calving and 30 days post-breeding. If you do that, the tests are quite accurate. We've looked at different ways to use these tests in a management system. Again, this is my student Elena, veterinarian from Brazil. This is Ryan. He did his master's degree with me. And we asked the question, if we had one of these tests, what could we do with it? Well, this is a timed insemination for first breeding. We said, what could we do with one of these tests if we had it? We could give GnRH early. This would be a day 25 resync, so we give GnRH. On day 27, now this is early for a PAG. I said 28 to 30, so we're a little bit early here. But we took a blood sample to test for PAGs. And if they're open, we can then, 5 days later, finish the protocol. So that's kind of what we looked at. And so we did a study. The students were out collecting samples early. We shipped off the blood samples. Monsanto developed this test, actually. They ran the assay. And then they would email us the results back. That's my building at the University of Wisconsin, Dairy Science Building. And then we would email the results back to the farm. So the point is, this is not an on-farm test. It is not a cow-side test. It takes some time. You got to catch the cow, take a sample, let her go, get the result back, find the cow, and catch her and restrain her and do whatever you're going to do. So we compared the accuracy of the PAG ELISA to ultrasound. And I'll just show you this one number here. The accuracy of the PAG test on day 27, which is actually a day early, was 94.6%. Now, the accuracy of these tests is never 100%. So the question should be, is 94.6% accuracy good enough? And based on some data that Victor Cabrera has worked with, he's done an economic analysis of this, and he says, yes, 94.6% is good enough. Because what that means is that on occasion, you're going to make a mistake. You're going to give on very few cows, you'll give prostaglandin to a pregnant cow, or you'll call an open cow pregnant. But the benefit of calling a cow open earlier in the vast majority of cows that it's accurate for outweighs the mistakes that you're going to make with the test. A couple other things about these tests. This is a study by some others, Romano and Larson in 2010. They did an interesting study where they collected blood samples on day 28, on day 30, and on day 35 from the same group of cows, and they really showed the same things that we did here. Their accuracies are very close to ours, which is really great when those kind of things match up. What I want to show you here, though, is that there are always three outcomes to a pregnancy test. And you can see 8.5% unknowns. You got pregnant, open, and unknowns. It's 4.8% on day 30 and 3.3% on day 35. So you're going to get some unknown outcomes in these tests. The last thing, I think this is close to my last slide, and the latest thing that has happened with these tests, what I was showing you before was the blood test. So you have to collect a blood sample to do the bioprint assay and to do the DG29 assay. IDEXX has now developed a milk-based pregnancy test, and they released it, kind of made a big presentation at World Dairy Expo this last year, and based on that, the data are what they're showing is you have to be greater than 35 days post-breeding now, so not 28 to 30. You got to be more than 35 days post-breeding, and again, you got to be 60 days post-calving. The way that they've marketed this, because it's in milk, is through the DHIA organizations. You can read that here. They're marketing it through DHIA. So most people are on DHIA tests. You're going to test the cows once a month to determine whether or not they're pregnant. The question I have for everyone out there is once a month pregnancy testing enough? And in my mind, it's not frequent enough. Most farms, and I would recommend at least every other week, if not weekly, are identifying open cows. Now, there are ways you can take blood samples every 2 weeks or every week and get them analyzed. It's just a little bit more of a hassle. There's one data set out that looked at the accuracy of this test. It's by Stephen LeBlanc. It's a new paper in 2013. And they basically just looked, this test is marketed as a recheck. So the first check you do with your veterinarian or with a blood test, and then he just looked at the outcomes using transrectal palpation, and you can see sensitivity, specificity, positive and negative predictive values are rather high with the test. We're actually doing some work with this test right now. Now, one of the problems that's happening is that if you think back about the PAG profile, if you remember, PAGs come up around day 20, then they kind of take a dip down, and that's about when we want to do that pregnancy recheck. And the problem is the PAG levels are many-fold lower in milk than in blood, and I think we might just be pushing the sensitivity of the test at that particular point in time. So I think, Kathy, that is my last slide. At least when I try to advance it, I cannot go any further. So I think that's the last slide that I have in my presentation. And I think I am exactly right on where I need to be here as far as the timing goes. So, Kathy, do we have any questions from the audience yet?
Well, we have several people that are typing.
Yeah, I see that.
I think I have a question, kind of a general question that I'll ask while people are typing in their questions. And back to the accelerometer systems, I wondered if there are some key factors that people should consider, or key questions they should ask when they're considering the purchase of an accelerometer system.
Well, certainly, I think there's a lot of things you have to consider, and one of the things that I think has to be considered is what kind of an environment are the cows in? These systems are detecting an increase in activity, and so the barn has to be designed so that the cows have enough room to have this social interaction, this increase in activity. One of the things that can happen in some of these barns is that when it gets cold out and it gets slick in the barns, they don't show as much activity perhaps. I think the system is sensitive enough to see the increase just moving around that the cow would have to probably pick that up. An interesting question I've gotten before when I've given this talk is, what about cows in a tie stall barn? It's interesting, these are not pedometer systems. Pedometers are measuring steps. These activity monitors are accelerometers measuring motion in 3 dimensions. And so the question is, do cows move enough in a tie stall barn to detect activity? We don't know the answer to that yet. At least I don't. I don't know if the companies have looked at that, but I wouldn't. I would think long and hard before getting an accelerometer system where the cows were tied down all the time, for example. So those are a couple things, and then I think that spreadsheet tool that Victor Cabrera has, looking at the economics of these systems, I think that's a real important thing that you want to look at, and just punch your numbers in. And again, I would highly encourage that people do 2 things with these systems. You got to breed cows twice a day to estrus. You got to go out, generate your list in the morning, generate your list in the afternoon, go out and breed the cows the system says is in heat. And I'm a big proponent of the fact that some level of synchronization is going to improve reproduction on almost any dairy, because it deals very effectively with the cows that are either ovulating and not showing estrus, or the cows that are truly anovular. And that's a significant proportion of your cows. As I said, it's about, it ranges from farm to farm, but it's going to be about 30%. So those are some of the things that I really would want to consider when looking at the accelerometers.
Okay, thanks. We have one question from the group so far. Would you recommend different timing from onset of heat from the activity monitor to insemination in different lactation groups?
Yeah, it's a really good question, and we don't have a really good answer to that yet. If I were to do some more work with these accelerometers, what we would want to try to ask is there, for these, why is it so variable among cows? in the timing of ovulation in relation to this increase in activity. I didn't go through all the data in that first study. Anybody who wants to, you can pull that paper out of the Journal of Dairy Science and you can look through it. One of the things that we did find is that as milk production increased, the peak activity also decreased. So as milk production increases, peak activity actually decreased. And it very well could be that milk production level may delay the timing of ovulation. And I think if you want to look at a mechanism for that, my colleague Mila Wiltbank here at UW-Madison has been working on a hypothesis that as feed intake increases, milk production increases. And also as feed intake increases, the clearance of these ovarian steroids, progesterone and estrogen, in the liver actually increases. So you can imagine a physiologic scenario when you have a very high-producing dairy cow and she has regressed her corpus luteum and you've got a follicle that's growing up. It takes longer to overcome the liver metabolism of estradiol before you get estradiol to accumulate in the blood to a threshold that's going to induce estrus activity and ovulation. And we actually showed in that paper as well that there is some suggestion that that might happen. Am I ready to go out and make a recommendation that if a cow's giving 10 pounds more milk, we delay her by 2 hours? Not yet, but I think that that's a very interesting thing that needs to be pursued. And I'll just go on and try to elaborate a little more on that question. One of the things that I was a little worried about was people would look at those data and say, okay, there's a lot of variability in when cows ovulate when we go out to breed them. So what would happen if I gave an injection of GnRH at the time of breeding when using an accelerometer? And that's a second facet of the study. I didn't have time to go through that. There's data to show that giving GnRH at the time of insemination might have a slight increase in conception rates. However, this was done in a meta-analysis. However, the studies that show the biggest difference are also the smallest, and so they have the largest confidence intervals. And so what we did is we randomly allocated cows to either get 100 micrograms of GnRH at the time of insemination or not get that. And the thinking is if we could give that GnRH and kind of tighten up this timing of ovulation, maybe we could improve the conception rate. We had over 400 cows in each of those groups, close to 500 cows in each of those groups. There was no difference in conception rate if we gave GnRH at the time of breeding or if we didn't give GnRH at the time of breeding. And in my mind, it's because we give the GnRH too late. There's actually some good data from Israel that shows that if we could give GnRH at the onset of activity, or the onset of estrus is what they did, they actually increased conception rates, especially for the cows in heat stress conditions. So we wanted to actually do that as a part of the study, but this was an on-farm study, and it's a very difficult thing to do because you got to run out and you got to get the GnRH to the cow as soon as she increases her activity, and then you've got to go back out in a few hours later and breed the cow. So there's not going to be an easy fix to this, but if you want to breed cows at a higher conception rate based on the timing of insemination, I would say the best recommendation I would make is to synchronize the cow because we know that we can synchronize ovulation very, very tightly.
Okay, thank you. We have another question that says, what are your thoughts on GONA breeding?
Yeah, the GONA breed is this gets into a whole other topic that I really did not put into my presentation, but we can certainly talk about it. What has happened is that I did talk a little bit about synchronization. Use of GnRH in combination with prostaglandin to synchronize ovulation is technically an off-label use of those particular hormones. And so we've been kind of flying under the radar, I guess you would say, using those particular protocols. But what's happened is a pharmaceutical company from Australia named Parnell has gotten FDA approval for an OVSync protocol. and they use a gonadorelin acetate, or a GnRH, that they call Gonabreed. That is their product. And they use Estraplan as their prostaglandin, which is a cloprostenol product. And Gonabreed is a gonadorelin acetate. It's the same compound that we have available in the other GnRH products here in the United States, so there's no difference there. It's formulated in a higher concentration, so rather than most of the products, the other products you give 2 cc's to deliver a 100 microgram dose. In other words, they're 50 micrograms per mil. The Gonabreed product is 100 micrograms per mil, so you'd only give a 1 mil dose. People have made a lot of comments about that. We did a study a long time ago where we gave either a half a dose in 1 cc or a full dose in 2 cc's of GnRH. And I kind of made a big deal about the 1 cc dose using a certain needle size and a certain syringe size and all that stuff, with just the thinking that we have to get it into the muscle of the cow. I don't think that's a big problem as long as you do get it into the muscle. And as far as data behind that particular product, the company itself has a lot of data. I have not seen any independent data comparing Gonabreed to any other products. Independent data meaning some other university researchers have actually compared them. So Rodney, that's really all I can comment as far as the Gonabreed product is concerned. I don't know if you have any follow-up questions on that or not.
I don't see any other questions. Oh, it looks like Rodney's typing, so looks like we'll get another question. Oh, okay.
Oh, great.
Rodney says thank you. So evidently you answered the question.
Yeah. This whole thing with Parnell coming out with their FDA approval has been a big deal. I mean, it's a big topic of discussion out there. I know amongst veterinarians it's been a big topic of discussion, and dairy farmers are learning about it as well. So at some point I should probably do a little bit of proactive extension programming in that particular area, because I think people are interested in it. It's something that's definitely affecting the industry.
Okay. We have another question that asks, what % of dairymen are using these protocols?
Yeah, that's a good question, and the best way I can answer that in a data sense. I mean, I don't think people have a good idea across all cows in the country. We did a survey where what we did is we used the Alta Genetics Advantage Test herds. So these are herds across the United States that would be considered to be very, kind of the top producers, top dairy farms. So the farms were large. I mean, average farm size was over 600 cows. They're giving about 34 kilograms of milk. They had culling rates about 34%. They're very good farms. And when we asked them, do you use an estrus or ovulation synchronization protocol, it was well over 70% of them said yes. So we also asked a few questions about how they were using these programs. I'll just tell you, I just got back from Holland and Germany, and I've been all over Europe and South America. These protocols are used very extensively for dairy cows, usually in combination with estrus detection. And as I said in my presentation, they work very well for the cows that we don't see in estrus. So they can be a very effective tool to get those particular animals pregnant.
Okay. Next question is, what is the most effective financially, heat systems or pure OpSync on large farms?
So if you go back to, in my presentation, I did discuss that, and the question is, at least for first breeding, should I cherry pick to estrus? Should I breed 70% of my cows to estrus after the second prostaglandin and OpSync the rest? Or should I just do 100% timed AI to first breeding? And when we asked that question economically, based on the data from the actual experiment, those two were about the same. Okay, each of them had their own advantage. Estrus detection, you'll breed cows earlier but at a lower conception rate. Timed AI, you'll breed cows later but at a higher conception rate. And those two things wash each other out. We haven't looked at an entire system. You can do that with Dr. Cabrera's model very easily just by punching in conception rates. One of the things that I have found is that farms that do 100% synchronization and then resynchronization, so they just break out the time to AI for first breeding, do a preg check, and resynchronize open cows, and they don't do any heat detection. That's very difficult to do because it limits your service rate across time. And the only farms that do that have exceptionally high conception rates. Most farms are going to use a blended approach that use both heat detection and timed insemination, and I think that that's probably the best way to go.
Okay. Another question. You talked earlier about you didn't want conception rate lower than 30%. What would you consider an ideal conception rate?
Yeah, so I kind of look at conception rates in a number of ways. So if the question is first breeding, I would say first breeding to a standing estrus or to rub tail chalk or to an accelerometer, I like to see conception rates in the mid 30% range. I see them in the upper 30s. On occasion, you'll see someone that can get into the lower 40% conception rates. Below 30%, I think that there's problems with either timing of insemination or something going on with the way the semen's being handled or something with the breeders or something going on if it's actually lower than that. If I'm setting up cows to 100% timed AI on a pre-sync OBSync protocol or on a double OBSync protocol, my benchmark is different because conception rates are higher when you use those synchronization protocols for first breeding. We'll typically see conception rates in the low to mid 40% range coming off of a pre-sync OBSync, and we can see conception rates on a double OBSync or a G6G type of a protocol that are in the mid 40s and pushing 50%. The other thing you have to look at is the parity group, and I skipped over that slide. First lactation animals have higher conception rates than older cows do. So it's not a simple thing to look at conception rate. There's a lot of different ways that I tend to look at it, and but kind of a benchmark in that study I just mentioned, that 30%.
Okay. Well, it looks like we've covered the questions that have been asked, and I would like to thank you for your sharing all your information and taking time to participate in this webinar today.